So can you tell us a few words about yourself and about the tool you're going to show us?
Awesome. Yeah, for sure. So my name is Gev. My background is in applied math. So I've been building software since 2010. So quite a bit. So in the past 6 years, I've been mainly focused on building machine learning infrastructure. Spent quite a bit of time in Europe. Now basically sharing my time between Europe and the Bay Area. I'm currently focused on AIM. So basically what AIM is, it's an open source magic library that ingests a lot of machine learning metadata and gives you ways to compare them in a deep fashion, but with very few clicks. So essentially, we are building this concept of explorers, which are ways to. It has several components essentially. It allows you to. So it allows you to select the machine learning metadata, say a metric, say an image. It allows you to always have a context in front of you around the machine learning training runs, like basically all the information that has been as part of your training run. It allows you to filter them and query them, because we save the machine learning metadata in a way that you can query them at the deepest way, for instance, through the hyperparameters, especially if there's lots of description of hyperparameters, you can query them in a very detailed fashion. Like through your environment variables, you can query them through your hyperparameters or maybe the pre-processing steps, anything you want essentially. And all those different hyperparameters also become available as ways to manipulate your metrics, your images, your other types of metadata, to group them, to divide them into different, sections. And then there's also lots of manipulation, lots of tools to manipulate already selected metadata. And so all these together are then comprise the Explorer, which when you use it, you really in a few clicks get to really deeply see what's going on with your machine learning training runs. And so, yeah, AIM is essentially this library that allows you to get a lot of that metadata, to query them programmatically, and then use explorers on top to compare them.
Yeah, and I checked the web page. The interface looks pretty neat, so I would really love to see this in action.
Cheers, cheers. So maybe I should share my screen, right?
Yep.
Just a second there. So this is basically the Git page. I have opened this to give you an idea of what it looks like integrating with your code, AIM, and then I will show you how the explorers work. So basically, once you install AIM, we enable this run object, which you create as inside your training script. So this run instance has basically two APIs. So the ability to attach any type of dictionary to it with a key, and then ability to track all sorts of different kinds of metadata, like images, like metrics, audio, text, all the regular stuff. And then we store it in a way that you can query them through your metadata and then compare them on the explorers. So what I will show you, because different machine learning projects have kind of different types of needs sometimes when you want to compare them in a different way. So I will kind of walk you through 3 different projects. First, I will kind of show you a round of one relatively more complete, because we keep shipping the features a little bit frequently. The demos aren't always containing all the features. So I will show you kind of what you can track in general with AIM. Like general what the tool looks like on the UI end of things. And then I will show you 2 use cases of how to compare maybe about 50 to 60 training runs with a few clicks and then also how to compare two different types of GAN trainings, one with exponential moving averages 0, one exponential moving averages 1, and how to see the evolution of the images in a very few clicks to really clearly see the difference between those two techniques. So yeah, so without further ado, this is just a second there. Yeah, let's pray to the demo gods. There you go. So essentially,
it's not running on your local host, right? It's somewhere in the cloud.
Oh yeah, so these are openly available demo websites. Yeah, AIM is self-hosted. So essentially, usually the way folks use it, they either install it on a remote server that for the whole team, or recently we have also shipped the remote AIM. So which means you can train your models on a separate machine than where you collect the data, and then you can send the data to the remote machine. These are essentially demo examples that are available like publicly for everyone that we usually share with the community. Yeah. So essentially, once you open AIM UI, which you open it with AIM up, this is what you see. There is this activity pane where you can click and immediately go to this runs dashboard. So on the left-hand side, you see these different explorers that we have already built, one with the runs, one with metrics, one with parameters, images, and scatter plots. And so what can you do with the runs explorer? Like straight away, as you can see, once you click the button, it brought you to this already pre-searched runs dashboard, where you can see the holistic, all your runs and all their information. This is a regular table with last values of your metrics like this in here. You can see then also the hyperparameters of each of those runs. And so to give you an idea of what this search looks like, basically everything you track with AIM, it becomes available as something you can search. So for instance, if I want to say run that experiment is equal to say FS2, it's going to leave me only the experiment where the FS2 are named FS2 experiments are like grouping mechanism for runs. And then each run has its own page where you can see every bit of data that you collected for that specific run. Like for this one, these are fast speech experiments. So there is going to be a lot of audio and text. So these are the parameters, the metrics. You can collect arbitrary number of parameters. You can get arbitrary number of metrics. You can also attach context to metrics. So for instance, when you're using TensorBoard, when you want to distinguish the train loss from test loss, you usually separate them into different log files, and then you end up querying them like that. What we have kind of added here, introduced the concept of context, where you can pass it to your track function like this in here. So you can pass any dictionary around each of the metadata you track, and then it will you will have, if you want to track test loss, train loss, you still track loss, and then they get differentiated by that context. So this is what you're looking at here. Folks tend to pass nowadays lots of them. This is pretty powerful. You can also use this to search as well. I'll demonstrate in a moment there. Yeah, so metrics, system parameters. I hope this one has distributions, but this one doesn't have distributions. So distributions allows you to essentially track at every layer the gradients, the biases, etc. All those distributions, you can really deeply analyze them. Images, right? So these are some type of wave images from sound, audios. Yeah. So essentially, this you can also this is everything you have tracked about single run is contained in this page. You can also track Plotly images. figures with the whole Plotly setup already pre-integrated. Yeah, so essentially this is how holistically the tool looks like. There is, I kind of showed how the Runs Explorer looks like. So how about I show you on a different project how you can, within a few clicks, analyze and compare about 60 machine translation experiments. So this is the metric explorer, right? So first step, what you do is the first click is let's pick the loss, the test loss. So essentially our goal here is to compare the test loss to test blue, which are the main metrics for machine translation experiments. So we pick the test loss and then we pick the test blue and then we search. What it's going to do, it's going to essentially stack those two metrics on top of each other, which is not so helpful. And this is where the superpowers come into play. Essentially, there is a lot of different tools here that will allow you to manipulate, for instance, the metrics. These are like very metric specific tools. So the first one that I want to show with you is this, the chart divider. So each metric is an object in name. So each metric that's an object has a name. So if you divide these two metrics by a name, it's going to produce two different charts. So now it's much easier. So suppose the experiments that we wanted to analyze were for specific learning rate, the one that we have tried for specific learning rate. So for that, I will just filter run.hperrounds. This is basically what I've tracked. So all of those are available. So I just pick learning rate greater than 0.0001. There you go. So these are the metrics we are interested in. And so the third step is, for instance, we have been experimenting with several different hyperparameters. But the one I'm interested right now is the max K, because it's been like I've tried 3 different values of max K, so I want to see how my experiments behave based on the value of max K. So we have this tool called the grouping, metric grouping tool, where you can pick every hyperparameter you have tracked. You can pick them, and then it will basically divide into clusters based on the value of the hyperparameter. So if I pick max K here, it will essentially divide into 3 different color clusters, one corresponding to max K equals to 3, another the purple one, the blue one to max K equals 1, and the green one max K equals none, I believe. Yeah, there you go, none. And so like at this point, we can clearly see that the training runs where the max K equals 3 are doing the best because it has the best test loss and it has the best blue. At any point in time while we're doing this, the context of the whole like experiment is available for us. So if I click at one of these runs here, I can it will scroll me down to that specific training run with all the information available for that. I can navigate to the training run. I can choose to delete that run if I need to, or archive the run. So this is a full-fledged table, like full context about the run. And you can also manage the columns, pin some columns to the right, to the left. So there's a full context always available. Or if you don't need to do that, don't need to see that, you can always hide it if that's the case. Yeah, and so, but sometimes, oh, there you go. But sometimes you also want to take this a little bit further, and then on the right-hand side, there are then metric-specific tools. So, for instance, I can aggregate these ones. So, what it will do, what this does is show the trends essentially of those clusters of different runs. So, I can also pick the max, for instance. It will show the best, for instance, the best blue. This is a specific run. If I click on it, it will navigate me to that specific run. And there is a bunch of other tools like I can, for instance, pick x-axis as another metric, the whole jazz. that comes with comparing, with metric manipulation, smoothing tools, right? Obviously the zoom in, zoom out, highlighting, modes, etc. I can say highlighting off. It won't be visible for aggregated, but yeah, to give you an idea. So this is how basically what Metric Explorer do. Within a few clicks, you can really compare lots of metrics in a meaningful fashion. So the next thing I would love to show is the Images Explorer. So, and these are generative adversarial network experiments. Basically, once you're training them, there's like two strategies of training, right? EMA enabled and EMA disabled, the exponential moving averages. So what I will show you is how within a few clicks to compare the way these GANs are training over time based off those two strategies. And I will do that for a specific run. First, let's query that run. So run.hparams name. So usually this is the name of, because we have several runs with several different data sets. So we're kind of only interested in met faces in this specific one. There you go. Okay, so basically what I want to do, I want to first group them by the EMA. So EMA has been passed as a context when the image was being tracked. So I can group them by the context, which means it will divide them into two different groups, one only the EMA 0 and one only EMA 1. And so that's usually, there you go, images context that EMA. So I just picked
EMA?
Oh, EMA is EMA is the exponential moving averages. So usually it affects how you train the model, and then so if it's disabled, you will see more sequential, kind of linear way of training. You will see some gradual, evolution of the generated images. But when it's one, you will see like black, and then wow, really good result. To give you an idea. So this is what usually you'll be looking for when you're trying to analyze these types of experiments, among other stuff, of course. So now it has divided into two different groups. And then if I also go here and pick the record.step. So imagine the way these images are tracked is during training, at each time when it's tracked, it tracks like a batch of images where a step is associated with that, an iteration, an epoch is associated with that. And so at each step, there is a good number of images being tracked. So what we want to do, we want to compare them at these two different strategies. We want to compare the images tracked at the same step, essentially. To have an idea. So once I group them by the step, now I see it. So these are all the images tracked at step 0, all the images tracked at step 1, right? And then if I scroll down, I can see the evolution, right? But sometimes this is really hard to compare in a way, because if you scroll up and down, it's not really helpful. So we have built this stacking tool, which if you press, it's going to stack the images on top of each other, and you can kind of slider up. So if we, for instance, try to compare these two steps like this, yeah, there you go. You see, as I mentioned, EMA 1 usually converges at the end better than EMA 0. So at the same step, this one is already showing something, but then at the last step, you will see the EMA 1 has much cleaner, better pictures than the EMA 0. Let me actually make the size of images a bit bigger here. And if I just do this, and what if I even just once and for all, fix the size a little bit here. There you go. So if I pick the final images like this, So the one with the MA1 are like much better. So this is kind of in nutshell what AIM does. So we have built a bunch of different these explorers that are really sitting tight on top of the data, that allows the users to query, group, and compare them at scale with lots of experiment, with lots of hyperparameters, lots of metrics, with the context always at hand.
Yeah, that's pretty impressive. Must be quite a lot of work that you put in this thing,
Yeah,
right?
yeah.
So
We have
how,
been
how
working
large is your
for
team?
about 18 months now.
How large is your team that works on this?
There are 12 core contributors who are mainly, and then we have overall 27 contributors.
Mhm. And if somebody wants to contribute, how do they go about this?
Oh, the contributions are more than welcome. We have a Slack channel. We are still putting together the more formal contributing guide, etc. So right now, the best way is to come into our Slack channel, ping the authors, ping the committers. Like it's really easy to see, by the number of commits in the GitHub Insights. Everyone is available there. Everyone is super friendly, super welcoming. So there is lots to contribute to documentation. My gosh, to JavaScript, there is so much JavaScript that needs to be written.
Yeah, I could see this from your UI, right? So it's very UI heavy, and for that you need to do a lot of JavaScript, right?
Oh yeah, and we're now integrating into Kubernetes and lots of other, tools like that. And so there's a lot to contribute. Yeah, so everybody's welcome to give it a try, share feedback, and possibly try to contribute.
So to summarize, if somebody wants to contribute, they should go to Slack and then say hi and ask, hey, I want to help. What is a good first issue that
We
you
have
need help with, right?
the labeled good first issue. There's a good number of them. Or they can basically go to GitHub, and then if they take on this, just mention under the issue they're taking it on. And yeah, and if there's some design discussion, usually happens under the issue to keep the context there. Yeah, that's usually the process now. We are planning to have those regular documents about contribution, so down the line.
And what are your plans? What do you plan to work in the nearest future?
Sure. So the concept of explorers, the way I shared, this is just the initial version of what we are trying to build. And so in the near future, we are going to take this to another level. So you see, if the big difference with existing tools is that they're very dashboard heavy. Everything is a dashboard. And so the way we have thought initially is it needs to be super actionable. You need to be able to, like, in really short period of time, compare them. And so we are going to add some dashboard functions as well around the explorers and really take this to another level. And the second group of work that we are going to focus on is around integrations. So for instance, we already have a good number of folks in our community have integrated them with their Kubernetes clusters. We are planning to have an official Kubernetes integration, hopefully well tested. Yeah, and there is a good number of infrastructure tools that we already have been hearing, requests for integration, like workflow scheduling, different data processing tools, data versioning tools. Yeah.
Great. And do you have any advice for anyone who is watching this?
Yeah, that's an awesome question. So I think like all of us who are contributing to AIM are big believers in iterate fast, fail fast, but then be open to listen. So I guess when building machine learning, iteration is key both on the code level, because machine learning literally iterates to learn, but also building the very early version, even scrappy, will teach you a lot. and then it will enable you faster to learn from all what you did right, so essentially what I'm trying to say is, so if you're building machine learning models, if you're trying to figure out the machine learning infrastructure, try to really first put the high level problem, and then try to make a scrappy first version, and then iterate on it, and then eventually, really build towards something final, regardless of what the tools you're using.
So iterate fast.
Iterate fast.
Oh, fail fast.
Not fail fast. Hopefully not too much, but
or not fail, right? Okay, yeah, thanks a lot. Thanks for showing us this tool. You put a lot of hard work. I could see this. This is a great tool. So thanks for finding time to show it to us. And for anyone who is watching, go to GitHub and give them a star. They really deserve it. It's a great project. So thank you again for showing it to us.
Cheers. Thank you for having me. Love the chat.
Yeah, okay.